Our today's lesson plan is correlation and regression. This is the first section of the three sections that we will cover in chapter 4. The first section talks about scatter plots, the basic idea between relationships, pictorial representation, and mathematical outcomes of quantification of relationship between a pair of data. In this section, we will understand and learn how to construct and interpret scatter plots for two quantitative variables, calculate and interpret correlation coefficients, determine whether a linear correlation exists between two variables. The couple of things that I want to mention before we start talking about the concepts, one of them is we are going to study a linear relationship. What do I mean by saying a linear relationship? If you have two variables, both of them representing two quantitative variable types, and you are interested to know whether you can find a straight line depicting the relationship between two variables, then that type of study of interrelationship is called linear correlation. For example, say we are interested in learning whether studying for a certain number of hours before your test has any positive or negative relationship with getting a better grade in the test. But we also want to understand if that relationship can be described by drawing a straight line where the x inputs are number of hours studied before the test and the y outputs are the grade outcomes from the test. So this section is going to help us first learn how to draw a pair of data where the first data is called independent data and the second data is called the dependent data. And hence, using those drawings to pictorially understand about positive or negative relationships. So let's start talking about scatter plots. A scatter plot is a graph of points x, y, each of which represents one observation from the data set. One of the variable is measured along the horizontal axis and is called the x variable. The other variable is measured along the y-axis or the vertical axis and is called the y variable. A positive linear relationship between x and y will imply for smaller values of the x variable, we will be able to associate smaller values of y variable, whereas larger values of x variables will be associated with larger values of y variable. In other words, if x increases, then we would be able to say y also tends to increase. Whereas a negative linear relationship between two variables x and y will interpret that smaller values of x are associated with larger values of y, or larger values of x are associated with smaller values of y. So as earlier, if we increase the value of the x variables, the y variables will have the tendency of decreasing. And if we find out that the values of x variable are not associated in a particular linear way for any range of y variables, then we will call that situation no apparent relationship. In other words, as x increases, y tends to remain unchanged. No linear relationship will be the situation when the x variable and the y variable are related but not by depicting a straight line. And we will see examples of all four of these situations in our later slides. So what we have learned so far, if we draw a pair of values where the first value is x and the second value is y, then we get a scatter point. A graph consisting of a bunch of scatter points is called a scatter plot. After doing a scatter plot, if we see the tendency in our graph that for increasing x's, our y values are also increasing, or the stream of point is rising, then we call that type of relationship positive relationship. Whereas if increasing values for x has the tendency for the y values to decrease, or the stream of point in the scatter plot is falling down from left to right, we call that negative linear relationship. If changing the values of x doesn't have any effect in the change of the values of y, or in other words, if y values remain uniform in the scatter plot, then we call that situation no apparent relationship. And finally, a non-linear relationship is a relationship where changing values of x will have impact in the values of y changing, but not in particular, like a straight line. Then we will call it a non-linear relationship. So let's look at the following graph. We have four different situations. The first situation is a stream of point, and if you look at this stream of point, you will see that the stream is going up as we are going from left to right on the x-axis. This situation is called a positive relationship between x and y. Whereas in our second graph, the stream of points are falling down as we are going from left to right on x-axis. So as we are increasing the value of x, our y values are decreasing. This is a negative relationship. If we look at the third graph, as x values are increasing, y values height-wise is not either going up or going down, depicting the situation for uniformness in our y variable values. That is a situation of no apparent relationship. Finally, in the fourth graph, you see a very nice shape depicted in a scatter plot. So we can say that as x values are changing, y values are changing, maintaining a certain pattern. In fact, this is a pattern for a parabola. But it is not a straight line pattern. And we call this situation a non-linear relationship. In this section, we will be interested in studying and analyzing situations where we have two variables and we are trying to understand the existence and the quantification of any linear relationship between these two variables.